Have you ever wondered why some functions in mathematics can't accept certain values? Or why, when you're graphing a function, some x values just don't seem to fit? Welcome to the fascinating world of domains in mathematics, where we dive deep into the concept of what a function can accept and what it cannot. Scene script. Picture a function as a machine. You feed this machine with inputs, and it churns out outputs. But not all machines can process every kind of input, right? Similarly, in mathematics, the domain of a function is the set of all possible input values that the function can accept or process. In other words, it's the set of all values that we can plug into the function's input variable and get a valid output. Now we can express this domain in set notation using curly braces. For instance, the domain of the function f(x) equals the square root of x is the set of all real numbers greater than or equal to 0. We can write this as x belongs to real numbers, x is greater than or equal to 0. The domain of a function can be restricted by a few factors. Firstly, undefined expressions. If a function's formula contains an undefined expression, like dividing by 0 or taking the square root of a negative number, the domain must exclude all values of the input variable that would cause that expression to be undefined. Secondly, discontinuities. If a function's graph has any points of discontinuity, then the domain must exclude those points too. Sometimes the domain of a function may not be explicitly stated. In such cases, the domain is assumed to be the largest possible subset of the function's input variable type that the function can handle. For example, the function f(x) equals x squared is defined for all real numbers. Therefore, its domain is assumed to be the set of all real numbers, even if it isn't stated explicitly. Output. Let's look at a few examples of domains of functions. For a linear function or a quadratic function, the domain is all real numbers because these functions can handle any real number as input. For a rational function, the domain is all real numbers, except for the values that make the denominator 0, as we can't divide by 0. For a radical function, the domain is all real numbers that make the radicand, the expression under the radical symbol, non-negative. For an exponential function, the domain is all real numbers. And finally, for a logarithmic function, the domain is all positive real numbers, as the logarithm of a non-positive number is undefined. Understanding the domain of a function is crucial in mathematics. It helps us know what values a function can be evaluated for and what values it cannot. It also plays a vital role in graphing functions, as the domain determines the range of x values that we can plot. So the next time you come across a function, remember to check its domain. It's not just about plugging in values and getting results. It's also about knowing what values are possible and which ones are not. That's the beauty of domains in mathematics.